So we're on to chapter 7 of MYP4 unit 2, and it's a revision of simultaneous equations, which is one of the big important topics in maths. And I've written, when you first learn algebra, you deal with a single equation in a single unknown quantity. So for example, 3x plus 2 equals 26. That's just one equation and then one value x that you've got to figure out. So it's easy to deal with that. Take away 2 from both sides to get 3x equals 24. Divide by 3 to get x equals 8. But simultaneous equations involve a system of two equations in two unknowns. I've put a little asterisk there because it could be 3 equations in 3 unknowns, or any number of equations in the same number of unknowns. So at the level you're going to have to deal with it, it's going to be 2 equations in 2 unknowns. So there's an example there. 2 equations, 3x plus 2y equals 37, which I've called equation 1, and 8x plus 5y equals 98, which I've called equation 2. So we've got to find the same value in x of x and y that will make both equations balance at the same time. At the same time being another word for simultaneously, hence the title Simultaneous Equations. So one way to solve simultaneous equations is by elimination, multiplying up equations in order to make the amount of x or y the same in both. Then subtract whole equations from each other so as to eliminate x or y. That's a bit abstract described by like that, but with actual examples it makes more sense. So the first equation was 3x plus 2y equals 37, and I've multiplied everything in the first equation by 5 to get 15x plus 10y equals 185. So that's just everything in equation 1, but I've multiplied everything by 5. And remember, an equation is like a balance, so as long as you do exactly the same thing to both sides, multiplying by 5 in this case, then it will still balance. And then I've multiplied everything in equation 2, that one there, by 2. So instead of 8x plus 5y equals 98, I've multiplied everything by 2, both sides, to get 16x plus 10y equals 196. Now the point of doing that is that I've made the amount of y in both the same. So I've multiplied both equations up so that they have the same of either x or y in both equations. Having done that, I can subtract whole equations from each other. So this second one I've called equation 4, and the first one here I've called equation 3, having already labelled the original ones 1 and 2. And I can do everything in equation 4 minus everything in equation 3. So 16x minus 15x gives us a single x. 10y minus 10y, and that's the key thing to this, the y's disappear, and 196 minus 185 gives you 11. So I've eliminated the y's from the system. And now that I've figured out x, we can plug it back into the original equations to find what y is. So we know that x is 11 now, and all I need to do is plug it back into, let's say, the first one there, and I can figure out what y is. So let's do that. Substitute into equation 1, 3x plus 2y equals 37. We now know that x is 11, so 3x becomes 33. 3 times 11. So we've got 33 plus 2y equals 37. And then I can just take away 33 from both sides to get 2y equals 4. Divide by 2 to get y equals 2. So we now know that y equals 2. Well, we could stop there, having figured out x and y, but it's always a good idea to check your answer with simultaneous equations. So this is where I use the other equation that I started with, equation 2. So equation 2 was 8x plus 5y equals 98. And if I put in the values that I got, so 11 for x, so 8x becomes 88, and 2 for y, so 5y becomes 10. So I get 88 plus 10 equals 98. And that's correct, so we know that we got it right. So we did some exercises in class, exercise 19D, page 381. And if you haven't done those yet, have a go at them. Looks like, yep, here's a few answers that I went through. So question 1, important to set it out nicely and logically. So I've lined up all my x's, all my y's, all my equal signs, all my answers down the page. Now in this particular case, I've decided to add equations to eliminate things. So in the original problem, you had x plus y and x minus y. So without even multiplying equations up, if you add the two together there, the y's disappear. So that's what I've done there. Pause the screen, have a closer look through it if you want. And there's another one that I did. So again, so that's question 7. So again, pause the screen if you want to check that through. And if you don't understand it, ask me in person. There's question 9 that I did in class. And again, pause the screen, ask me in person if you don't get it.